8-1 is the law of sines. You're going to be solving if you have cases where there's angle side angle or angle angle side, and also side side angle. All right, so just a little review. Acute angles are when they are from 0 to 90, less than 90 degrees, and then obtuse, which are huge, are 90 to 180. An oblique triangle is what you have not been dealing with. An oblique triangle means there's no 90 degrees. That means you can't use the Pythagorean theorem. You can't use x squared plus y squared equals r squared. So, also, you cannot solve a triangle if you only have all the angles, no sides. Okay, another thing you want to think about, and here it shows it visually here, but let me show you how I understand it a little bit better. If you think about the circle, okay, and we want sine, if you think about sine in this quadrant and this quadrant, it's going to be positive because sine deals with y, and y is positive. So whether we have 30 degrees here or we have 30 degrees here, which would be the 180 minus 30, so 150 degrees, it's still going to be the same thing. It doesn't change your answer. That's why sine of 180 minus x is the same as sine of x. Okay, now for theorems. Let me bring this down a little bit so we can see it. Okay, for the theorem, the law of sines. The law of sines just says that sine alpha over A is equal to the sine of beta over B, which is equal to the sine of gamma over C. Okay, remember that the angles coincide with their sides. So B goes with B, alpha goes with A, gamma goes with C. Now, something very important, you can use the law of sines if you have side angle, angle side, or angle side angle, and angle side. But if you have side angle side and side side, it's not. All right, let's go for the first one. It's always good to draw yourself a triangle. So here, what we're trying to solve for is we're trying to solve for B, gamma, and A. All right, I like to put down the information that I have. So right now, I know that I've got B and I've got beta, so I know I have that beta is equal to 45 degrees and 20 minutes. I know that alpha is equal to 28 degrees and 0 minutes. And I know that C is equal to 120 meters. What I'm missing gamma, I'm missing A, and I'm missing B. Those are what I need. Okay, in order to use, well, first, we can get gamma very easily because if you think about it, the sum of the interior angles of a triangle is 180. So we just have to add all these together. The only thing is we have to change our minutes to DD, decimal degree. So I've got to change 45 degrees and 20 minutes to just decimal. To do that, it's 45 degrees, and then you go 20 over 60. So in other words, we actually have 45 point, and 20 over 60 is 1/3. So that's going to be 45.33 continuing on forever degrees. Okay, now if we go to the alpha, we've got 28. So to find gamma, all we have to do is go, let's see, we've got 45.33 plus 28, which is going to give us, let's see, 45, we got 0.33, 8 and 5 is 13, carry the 1, 73.3. So if we subtract that from 180, we'll get that gamma is equal to 106.67 degrees. Okay, now we can go ahead and solve for A. So to solve for A, we need to think about our law of sines. So we want to solve for A, so we need the sine of alpha over A, and then see what we're given. We now have gamma and a side, so we're going to use the sine of gamma over C. And now we're just going to plug and chug. So we've got the sine of alpha, which is 28 degrees, over, we don't know what A equals, all over the sine of gamma, which is 106.67 degrees, all over C, which is 120 meters. So solving for A, let me just narrow this down a bit so I've got a little bit more room. Solving for A, we would have 120, the sine of 28 degrees is equal to A sine of 106.67 degrees. So therefore A is equal to 120 sine of 28 degrees all over the sine of 106.67 degrees. Plug it in your calculator and you'll get the answer. Don't forget to change your calculator to degree. And when you plug it in, you get 58.8, and it's meters. So A is 58.8 meters. Okay, now to solve for B, we're going to do the exact same thing, except for this time we're going to use the sine of B. So let's go for a different color, and let's go the sine. We're solving for B, so we need beta over B, and remember we're given gamma, so the sine of gamma over C. Now what we've got is the sine, and B is 45.33 degrees all over B, which is equal to the sine of gamma, which is 106.67 degrees all over C, and C is 120. All right, and make a little bit more room. All right, so to solve for B, I've got 120 times the sine of 45.33 degrees is equal to B, the sine of 106.67 degrees. Therefore, B is equal to 120 the sine of 45.33 degrees all over the sine of 106.67 degrees. So that gives us that B is equal to, when you plug it in your calculator, 89.1 meters. So now we've got that B is 89.1 meters. All right, it's your turn. Go ahead and pause and I'll put the answer up for you. Okay, here's the answer. I hope you got it right. Okay, this table here just tells you all the different situations that you could have. If you have an acute angle and no triangles, if you have an acute, you would have one triangle. You could possibly have two triangles. I've got tests for you, so don't worry about it. But you could have no triangles. I know that sounds crazy, but it's true. Okay, the first thing you want to do is draw your triangle. And let's label it. So I'm going to say that this is gamma, so this is C. This is alpha, so this is A. This is beta, so this is B. All right, A is equal to 47. B is equal to 23. And alpha is 123. We always want to find beta first. So we're going to use our law of sines. Okay, so first let's see, what do we need? We need gamma, we need beta, and we need C. Okay, law of sines. So we know we have alpha, we have the alpha angle and the alpha angle and the alpha side. So we're going to use the sine of alpha over A is equal to, and we're going to look for beta, so the sine of beta over B. Now let's just plug and chug. The sine of 123 degrees all over 47 is equal to the sine of beta all over 23. So the sine of beta is going to be 23, the sine of 123, all over 47. So in order to get rid of this sine, we're going to use the inverse sine. All right, when you plug that into your calculator, you should get that beta is equal to 24 degrees. If we know what beta is, that means we can find out what gamma is now, because we've got two angles. So remember that 123 plus 24, and we want to subtract that from 180 in order to get gamma. So we got gamma is 33 degrees. All we need to do now is find C, find our side. So let's see, I want to do, let me change my colors. All right, so I want to find C, so I'm going to do the sine of gamma over C is equal to, and I might as well just stick to alpha over A. So I've got the sine of 33 degrees over C is equal to the sine of 123 over 47. So to solve for C, we would have C sine 123 equals 47, the sine of 33. So C is going to be equal to 47 sine of 33 all over the sine of 123. And so you get C is going to be equal to 31 centimeters. Now we need to check to make sure that we don't have another triangle. So we're going to do alpha plus beta. Alpha plus beta is going to give us 33 plus 24. 33 plus 24, oh, excuse me, 123, not 33, 123 plus 24, which gives us 147. We know that we can add another angle to this to get 180. Now let's make sure we don't have two triangles. So what you're going to do here is you're going to go, you need to get your second beta, so we're going to go 180 minus 24, and that's going to give me 160, 156, and now I'll go alpha plus my other beta, 156 and 123 is way over 180, so we only have one triangle. Okay, it's your turn. Go ahead and pause and I'll put the answer. Okay, so here's your answer. Notice when I checked, it was 217. There's no way I can have two triangles. Okay, let's go to number 3. Number 3 says you have no triangles. So first thing we're going to do is draw our triangle. So let's draw our triangle. Of course, in your homework, it's not going to tell you any of this, so you need to go ahead and solve it anyways. All right, so let's go ahead and label stuff. So I've got this is gamma, this is C, this is alpha, this is A, this is beta, this is B. A is equal to 27 inches, B is 28 inches, and alpha is 110 degrees. We always want to find beta first. So the sine of beta over B is going to be equal to, we've got the side and the angle, so the sine of 110 over 27. So B is going to be equal to 27. Oh, wait. We've got what B equals. Sorry. B is equal to 28. We're going to find beta. So to find beta, we've got the sine of beta is equal to 28, the sine of 110, all over 27. So we're going to get rid of the sine, so we're going to multiply by the inverse. And when you go through and do that one, you should get that B is equal to 77 degrees. So now we can find gamma. We can just go 110 plus 77, which gives us 180. 187, and wait a minute, if we've got two angles are 187, that can't be. It has to be less than 180. No triangles. Okay, it's your turn. Go ahead and pause and I'll put the answer. All right, here's the answer. One thing you need to remember that the angle opposite, the side opposite the angle, so 57 degrees, that's 64, which means that if B is, since the opposite side is 79, beta has to be bigger than 57. Remember that the sides coincide. That's why there's no solution. Okay, let's go to number 12. Here you've got two triangles. So if we solve this, we're going to go ahead and do the triangle first. Okay, this is gamma, C, alpha, A, beta, B. A is 1.0, B is 1.8, alpha is 26. Okay, so I want to find beta, so I'm going to start with that first. So I've got the sine of alpha over A is going to be equal to the sine of beta over B. Therefore, the sine of 26 degrees over 1.0 is equal to the sine of beta over B is 1.8. Okay, so to solve for the sine of beta, we would have the sine of beta equals 1.8 sine of 26 degrees all over 1.0. We want to get rid of the sine, so we're going to do the inverse. And when you do, you get that beta is equal to 52 degrees. All right, so let's check real quick. Alpha plus beta. Alpha is 26 plus beta, which is 52, which equals 78. So we know we've got one triangle. Now let's try the other one where we want beta prime. So we're going to go 180 minus beta. So we got 180 minus 52, which is going to be equal to, what, 130, 128? So alpha plus our other beta would be, alpha is 26 plus 128. That's equal to 8 and 6 is 14, 154. So we have two triangles that we have to consider. We know that alpha is going to stay the same, which is 26. Our beta, second beta, is going to be equal to 128. So we're going to have to find our second gamma and our second C. And then here we've got that beta is equal to 52. We need to find our gamma and we need to find our C. So let's bring this down a little bit and let's start with the first one first. The only thing we're missing is our C. So let's go and do C. So the sine of gamma over C is going to be equal to the sine of alpha over A. So the sine, oops, we didn't find gamma. We've got 26 plus 52 is 78. Subtract 100, and 80 we get is 102. There's our gamma, 102. All right, all over, and we don't know what C is, and then the sine of 26 over 1.0. So C is going to be equal to 1.0, the sine of 102, all over the sine of 26. Okay, so we end up with C equaling 2.2 meters. Now let's go to our other side. And we need to find our gamma, so we've got 26 plus 128, which we said is 154. So subtract that from 180, and we would get 26. So our gamma is 26. Now we want the sine of gamma over C is equal to the sine of alpha over A, so the sine of 26 over C is equal to the sine of 26. sine of 26 over whatever A is, which is 1.0. So C is equal to 1.0 sine of 26 over the sine of 26, and we get our second one to be 1.0 meters. Okay, so it's your turn. Go ahead and pause and I'll put the answer. Okay, so here's your answer. Hope you got it right. All right, now my retirement home. So we're going to do my retirement home. I want to know how far it is across the lake, my little lake. So I need to figure out what I got. So let's go ahead and start. Let's change a few things. So we're going to say this is alpha, so this is A. This is gamma, so that's C. And this is beta, so this is B. I want to know A. So first thing I need is I need another angle here. So to get another angle, all I have to do is go 124.3 plus 41.6. So 124.3 plus 41.6. My calculator's dying on me. Hold on. All right, that equals 165.9. And then I want to subtract that from 180 to get that this one is 14.1. So I'm going to do the sine of 14.1 over 125 is equal to the sine of 41.6 over, and my A is what I was looking for. So I've got that A is equal to 125, the sine of 41.6, all over the sine of 14.1. And what I should get is it is 341 meters across. Finally, it's your turn. We're going to find the distance of AC using the same thing as what we had before. So pause and I'll put the answer up. And here's what you get. Here's your homework. Good luck.